Mr. Jern here. I want to talk to you a little bit about units. So to start us off, I got a couple questions for you. Which of these is faster? A cheetah going 70 miles an hour or a bumblebee going 6 miles an hour? You're very smart. Cheetah, right? 70 compared to 6, no problem. All right, another question then. How about a human going 23.16 miles an hour versus falling rain at about 9-ish kilometers an hour? Okay, now we're getting into a little bit about why I wanted to talk to you about this. The answer is the human, because it turns out that that is about 6 miles an hour. The 9 kilometers an hour is about 6 miles an hour. Not very fast compared to how fast a human can run. All right. What about the speed of the Earth rotating around the sun at 18 miles per second compared to the spacecraft in orbit going about 17,000 miles an hour? All right, you're starting to see the point here. It's going to be the speed of the Earth, because that translates, or that equates to about 66,600 miles an hour, all right, compared to 17,000 miles an hour. And that's really what I want to get into, is this comparison. Okay, so another example, speed of bamboo grows about 4 feet a day. The speed of food through your digestive tract, about a foot per hour. Which one's going to be faster? All right, food grows pretty fast, or I guess maybe bamboo grows kind of slow, although 4 feet a day is kind of a lot. Because what it comes out to is, here's your conversions. All right, so what? Okay, we converted all to miles per hour. So you can make the comparison a little bit better, or feet per hour or whatever. And that's kind of, like I said, that's the point of all this. Units seem annoying when the teacher requires you to use them. It's like something that's got to tack on at the end, right? It's another thing to keep track of. But it turns out that units are like, if you could get used to these units and just keep including them, it's going to change your understanding of how physics works, or at least it's going to help you problem solve and work through these things. And things will make a lot more sense when you don't separate the math from the physics and it all becomes one. So working with converting is what I want to show you really quickly. I found that there's 3 levels of difficulty. Those are just things I totally just made up, but you'll see what I'm talking about. So here we are, 3 levels of difficulty. How many miles are in 3 feet? How many inches are in 2 miles? And maybe I'll phrase it slightly differently, convert 1.2 kilometers per hour into centimeters per second. Okay, so if you want to like get a little ahead, these are the answers, but how did I get to those answers? So first level of difficulty, first order of difficulty. I broke it into steps because that's kind of what I like to do. The first thing for converting 3 feet into miles is, and this is pretty much all of these, is I found it useful to make everything into a fraction. So 3 feet by itself is not a fraction, but if you put anything over 1, now it's a fraction. So done. Step 1, make sure it's in fraction form. Step 2, put a blank parenthesis right next to it. All right, you'll see why in a second. This is going to help you convert. Step 3, step 2 is really easy. Step 3, okay, now we're getting into something to talk about here. You know what, let me just laser pointer. 3 feet. Feet is on top of this fraction, this new fraction. And we want to get rid of that. We want to eliminate that. So I'm going to put feet at the bottom of this fraction. I'm going to make this into a fraction. And if feet are on the top of this fraction, the bottom of this fraction, it's going to cancel each other out. Now, you'll notice I'm not putting any numbers yet. Don't put numbers in until the end. Okay, what's next? All right. I could go from feet to miles. I know there's 5,280 feet in a mile. It's a pretty standard thing. You get to learn it. Usually it's given to you, that conversion. Sometimes, if you're not lucky, you'll have to remember it. You'll have to memorize it. But most of the time, it's a given because it's a pretty well-known number. So I know that I can go, here's the point. I know that I can go from feet to miles. I know the relationship between the two, miles and feet. And so because I want to eliminate feet, I put them on the bottom. And then I can convert it into miles. So I'm going to put what I'm trying to convert it to on top of that fraction. Then, only then, once I get the units in place to cancel out, then I put my numbers in there. So I know that there's 1 mile to 5,280 feet. Okay, that's just like I said, that's the given, that's the relationship. Okay, So then what happens now is those feet cancel out because 1 feet is on top, 1 feet is on the bottom. And if I multiply across the top, I take the 3 times the 1 mile, I get 3 miles. 1 on the bottom times 5,280 gives me 5,280 with no units. When I divide that out, I get my answer. Okay, I call it the first level of difficulty because like we know the conversion from feet to miles and miles to feet, 5,280. Okay. And you always want to put a box around your answer. That's always a good thing. Second level of difficulty, I suppose, is when you don't know exactly how to go from one to the other, but there's a path from one to the other. Okay, here's what I mean by that. Going from inches to miles, or in this case, from miles to inches. I don't know how many miles are in an inch. I don't know how many inches are in a mile. Not very many people do. But I could think of a path. Well, if I convert miles into feet, and then I could go from feet into inches. Okay, we have sort of a path. You have to plan it ahead a little bit. So step 1 is to make it into this fraction. So just like last time, 2 miles is not a fraction, so I put it over 1. Step 2 is to put a parenthesis, just kind of leave it kind of wide for you so you can write because you don't know how big it's going to be necessarily. I do know I want to get rid of miles, and miles is on top, so I'm going to put miles on the bottom right here. And then, like I said, I don't know how to go from miles to inches, but I could go from miles to feet. Okay, and you notice, no numbers yet. Don't put numbers in until the end. Trust me on that. You just get confused sometimes. It's something that doesn't need to go there yet, okay? Trust yourself. Now, I don't want feet at the end. Miles will cancel out, but feet will be left over. So now I know I want to go from feet into inches. So I'm going to basically do the same thing again as I just did. And I'm going to put feet on the bottom here because feet are on top right here. So miles will cancel out with miles. Miles on top, miles on the bottom. Feet on top over here and feet on the bottom over here. I can go from feet to inches. And that's kind of where I want to end up. Now that I've got that set up, now I can put all my numbers in. And the reason I say to wait on putting the numbers in is because if you try to put the numbers in first, you're oftentimes going to get confused as which number goes on top and which one goes on the bottom. So by establishing just with the units, which is on top and which is on bottom, well, then I could say, well, I know there's 5,280 feet for every 1 mile. I know there's 12 inches to 1 foot, okay? And if I had put the numbers in there first, I probably would have had things backwards. It would not have made sense. All right, so always put the units in first and then put the numbers in. Because then, now you're in math land, and you could just cancel out what gets canceled out. Miles on top, miles on bottom, feet on top, feet on bottom. That's going to leave us with inches. Multiply across the top. We got our 2 with no unit times 5,280 with no unit times 12 inches right here. And on the bottom, we got 1 with no unit times 1 with no unit times 1 with no unit. So 1 times 1 times 1. I finish all that out and I get this number of inches divided by 1. And then if I simplify that, there's my final answer. All right. Remember, the trick is, well, there's several tricks, but the main temptation you had to overcome is putting in numbers first or before you're ready. Set it all up with the units, then put in numbers. So let's do one more example. This is what I call level 3 because, again, this is me. I like to have levels of difficulty here, but you can see why we're getting a little bit more difficult because now we have a fraction already set up. So I'm going to treat it as such. Step 1 is to make it into a fraction. All right, cool. It's 1.2 kilometers per hour means 1.2 kilometers per that implied 1 hour. All right, fraction done. So I take that fraction. Step 2 is to make the parenthesis. I don't know why I call it step 2. It's like step 1.5, but whatever. It's an easy step. It's a good check. All right. Now I want to do the same thing as I did before. Step 3. I've got kilometers. I got hours. Doesn't matter which one I start with. I'm going to keep with what I've been doing, and I want to get rid of that kilometers. And I need to convert kilometers into centimeters. Now, I don't know how many kilometers are in a centimeter or how many centimeters are in a kilometer. I could do some quick math and maybe figure it out, and you can too if you want to skip a step. But I'm going to drag this out just a little bit because instead of going from kilometers into centimeters, I know I could go from kilometers into meters really easy. And I know I could go from meters into centimeters pretty easy. And this is, I I don't want to say easily, but without too much difficulty. I don't want to overcomplicate this. So point is though, no matter what you do, you're going to want to get kilometers on the bottom over here because it's on the top up here. Okay, that'll cancel it out. Now whatever you convert it to is going to go on the top of this fraction here. I'm going to convert it into meters because I know there's 1,000 meters in 1 kilometer. I'm not going to put those numbers in yet because I've learned that trips me up. And from what I've seen in all my students over the years, it will probably trip you up too. Now, this will leave us with meters per hour because hours hasn't been canceled out yet. I don't want that. I don't even want meters. I want centimeters. So I'm going to set up another little parenthesis here, and I'm going to put, because meters is on the top, I'm going to put meters on the bottom. And I know I could go from meters to centimeters because I know there's 100 centimeters in a meter. Okay, centa means 100. Once this is all done, the kilometers will have canceled out, the meters will have canceled out, and I'll be left with centimeters on top. I'll still have hours on the bottom. So I need to continue that. I need to put hours on top. Over here, I make a whole new parenthesis set. Hours is going to go on top right here because hours on top here will cancel out with the hours on the bottom of our original unit, our original units. Okay. Now, you can go from hours to minutes to seconds. So you could put another parenthesis here if you want to go from hours to minutes. I happen to just work with this a lot, and I know that there's 3,600 seconds in an hour. So I'm going to go directly from hours to seconds. If you want to go 60 and 60, that's cool, but I know there's 3,000 because 60 times 60 is 3,600. So I'm going to go from hours to seconds. If you need to go from hours to minutes to seconds, you just need another set of parentheses there. It's no big deal. All right, and now that I've got all this set up, I'm just going to recheck everything before I go and put numbers in here. Check everything. Okay, it gets faster the more you do this. Kilometers on top will cancel out with the kilometers on the bottom. Okay, it'll turn into meters. Meters on top will cancel out with the meters on the bottom. We'll turn into centimeters on top. That's where I want to stop with that. I put hour on top here. That's going to cancel out with the hours down here. We'll leave me with seconds on the bottom, and that's what I want in my final answer. So only now do I put in all the numbers. I know that there's 1,000 meters in 1 kilometer. I know there's 100 centimeters in 1 meter. And I know that there's 1 hour and is equal to 3,600 seconds. It's all just equivalency. How many of each? And see, this one I would have maybe put the wrong number on top because it seems like all the big numbers go on top. But by putting the units here first, that made it so I know, okay, 1 hour is 3,600 seconds. Or if you did 1 hour is 60 minutes, and then you did another one, 60 minutes, I apologize, 1 minute is 60 seconds, then you would have gotten the numbers in the correct place. Now I cancel out everything. Kilometers on top, kilometers on bottom, meters on top, meters on bottom, hours on bottom, hours on top, leaving me with centimeters on top and seconds on the bottom, which is what I want. Multiply across the top, I get these numbers on top. There's only 1 unit left. Multiply across the bottom, I get only 1 unit on the bottom. And when I complete that, then I just take the division and I get my final answer. All right, that's it. So in summary, just make sure that you're canceling out the units you want to cancel out and ending with the units you want. And very important in my experience from myself and like countless students over the years is don't put numbers in until you've got all the units set up to cancel out. Okay, that will, it won't even save you time if you try to put the numbers in right away. It just feels like the right thing to do, but it's not. It's just not helpful to do that. Okay, so hopefully that's helpful to you. Have a good day.